Have you wondered how the food you eat becomes nutrition that your body can use? It's a complicated process, and in this video, we're going to meet the organ that's responsible for bringing food inside of you. One would think that swallowing is the moment that food enters the body, but it actually takes a couple more steps to actually get inside of you because your GI tract is technically still on your outside. Your GI organs are exocrine glands. They produce and secrete enzymes to help break down food. And really, they're in the same category as your sweat glands that are obviously on your outside. These GI glands produce enzymes that break down complex carbohydrates and fats and proteins into simpler components that you are actually able to absorb. And that final absorption takes place in the small bowel. The small bowel is the GI organ that comes after the stomach and before the colon, and it's divided into three segments. Its first part is called the duodenum, or in other parts of the country, the duodenum. But whether you say duodenum or tomato, the duodenum lays right behind the retroperitoneum, the inner lining of the abdomen, and sits snug against the pancreas. This is a great place for the duodenum to rest because it lays right next to the pancreas and the liver from which it gets digestive juices. The duodenum is like the town hall of the GI tract. It's where chyme from the stomach meets up with pancreas juices and bile from the liver. Chyme is a marinade of food that you ate mixed with saliva and stomach acid, as well as other digestive enzymes produced by the stomach. Once chyme is soft and small enough, it's going to pass through the pyloric channel to exit the stomach and enter the duodenum. And once there, it'll be sensed by specialized cells called neuroendocrine cells. These cells recognize different fats and proteins and carbohydrates and coordinate with the other organs of the digestive system and the rest of the body to aid metabolism. These signals tell the gallbladder to squeeze out bile, which will help to digest fats. They signal that the pancreas needs to release enzymes that digest proteins and fats to break them down into simpler components. And they also tell the pancreas to start to release insulin to make the body ready to receive this onrush of sugar. The stomach contents are very acidic, and other neuroendocrine cells recognize that acidity and stimulate the pancreas to release bicarbonate, which will help to neutralize it and normalize the acidity of the chyme so that these enzymes will function optimally. While most nutrients are absorbed further down the GI tract, iron and other minerals like calcium and magnesium are absorbed here in the duodenum. The next portion of your small bowel is called the jejunum, and it characteristically looks like a 70s shag carpet because it's lined with innumerable little finger-like projections called villi. And if you were to look at those villi under a microscope, they have villi called microvilli. All of these work together to massively increase the surface area of the small bowel. And the jejunum is the site of most of the absorption of your nutrients, and so it particularly has this heavy shag carpet look. The dimensions of your small bowel are pretty amazing. It can be up towards 20 feet long and yet packs all within your belly, and its surface area is nearly the size of a studio apartment, if not even the size of a small house. That's how much surface area these villi add. And that allows it to more effectively absorb your food. And that's aided by these enzymes that have been breaking down your food that were first introduced in your stomach, in your pancreas, and your liver. The small bowel lining has its own role to play in digestion. It breaks down two-ring sugars into single components. It has enzymes like sucrase that breaks down common table sugar of sucrose into component parts that can now be brought into the jejunum. All of those digestive juices has made these nutrients relatively dilute, whereas inside of the cells of the jejunum, they're already quite concentrated, which means these nutrients have to push their way into a crowded room, and that takes energy. And so there's specialized transport pumps that bring these nutrients across the lining of these cells and package them inside the jejunum, where they can then be exited into the bloodstream, continue on their journey to the liver. But the story of your food isn't complete just yet. As chyme continues its journey through the jejunum, it is gradually depleted of the nutrients that we can extract from it. Once it enters the ileum, we're able to scavenge a few more nutrients, water, and electrolytes. But there's a specialized role of the ileum, and that is to extract vitamin B12 and to recycle bile salts. The body likes to recycle these bile salts for a couple of reasons. First, if they enter in the colon, they're irritating to its lining, and that will provoke diarrhea. Secondly, these are expensive to make, and so the liver would rather reuse them than to be forced to make new ones. B12 is vital to both produce red blood cells and to help insulate our nerve fibers so that they can rapidly conduct nerve signals. Disease of the ileum can result in poor absorption of B12, which leads to anemia and nerve problems. The small bowel doesn't function on its own. In addition to having the stomach, the pancreas, and the liver help it to enzymatically break down food, our gut bacteria help this process. The duodenum is high in acid, and its food contents move fairly quickly, which means bacteria can't grow too readily. But the jejunum is a chiller place and it moves more slowly. Acid from the stomach has been neutralized, and this becomes a more favorable place for bacteria to grow and to aid us in digesting those carbohydrates that we cannot break down. However, overall, the small bowel has a fraction of the bacteria that are present in the large intestine, and that is because of the ileocecal valve. This is a control valve that makes sure that the chyme flows through the small bowel and exits into the colon, but it doesn't flow backwards, and that helps to keep down the total count of bacteria compared to the colon. I hope this video gives you new perspective on how complex the small intestine is and deepens your appreciation for how your food becomes your nutrition. In future videos, we'll discuss other organs of the GI tract and the role that they play in this important process. Thank you for watching and be safe.